everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over factoring, specifically when a does not equal 1. And I know I have another YouTube video on factoring specifically when a is not equal to 1, but I did that problem and that set of factoring when we were doing factor by grouping. Instead, for these problems, we're going to do it a different way that a lot of high school courses use it. It's a quicker way to factor when a is not 1. So let's take a look at some problems and see how we would accomplish them. So it's important to go over the steps on how to complete this easier, more efficient way of factoring when your a is not 1. So first you're always going to see, is my a 1, is it not 1? When it's not 1, we have to look, is there a GCF that I can take out? If there is, do that. Now, is my a 1 or is it not 1? If it's not 1, what we're going to do is multiply our a and our c value. Then we're going to find the factors that multiply to whatever we get for our a times our c and whatever adds to the b value. So it must add to the b value and multiply to our a times our c. So the factors we find must add to our b value and multiply to whatever number our a times our c value is. Then we're going to use those numbers and put our a value, x, plus whatever number we found. A value, x, plus the other number we found, the other factor we found that satisfies that rule, and then we can simplify either the one factor or both factors, whatever ones need simplifying, by taking out a GCF, dividing out a GCF to give us a simplified full factored answer. Let's take a look at a problem to see how we would accomplish this. So we have this problem here, and a first key point is to understand what are we doing here. So I look at this and I need to see, is there a GCF that I can take out? If there is, I need to take it out. If not, I'm just going to continue with my problem regularly. So I look, I have 3n squared, 14n, and negative 5. None of them have a GCF other than one that I can take out. So I'm not going to take a GCF out. On the other hand, now I need to do my next step, which is B and AC. I have to make my BAC table. So I need to look, what is my B value? Looking at this, my B value is 14. Then I take my a value and my c value and I multiply them together. Well, the a value is in front of the variable squared term and my c value is my constant. So I'm going to do 3 times negative 5. So my problem is going to become, I make a table, my b is 14, my ac is 3 times negative 5, which is negative 15. I need to find two numbers that are going to add up to 14 and multiply to negative 15. When I think of this, I am thinking of one positive and one negative factor, and that is 15 and negative 1. When I add those two together, I get 14. When I multiply them, I get negative 15 like I wanted. So now I'm going to use my quick rule to get my answer, my factored answer. So I am going to take my a term, I'm going to drop it down, put my variable. Then I put my one factor that I found and put plus 15. I drop my a term down again, I put the variable, and then I put my other factor that I found. Now I look, can I take out a GCF from either of these two binomials? If I look here, there's no GCF other than 1. If I look here, I could take a GCF out of 3. So I divide a 3 out, and I get n plus 5. I get 3n minus 1. So that would be my factored answer. If they ask for the zeros, I would subtract 5 over, get n is negative 5. I would add 1 over, divide by 3, and get n is 1/3. However, this problem just wanted you to factor, so your final answer here would be this in factored form. If you had to find the zeros, you would continue. Let's take a look at another problem to make sure we fully understand what we have to do here. So now I have this problem, and I'm going to do the same process as I did before. I'm going to see if there's a GCF. I have negative 4, 12, and 7. Well, because 7 is prime, there's no GCF, so I'm just going to continue like I normally do, and I'm going to do my BAC. So my B is 12. My a times my c is negative 4 times 7, which is negative 28. I have to find which two numbers add up to 12 and multiply to negative 28. what I think. I could type it into my calculator, divide by each different number that I have, like divide by 2, divide by 3, see what happens. I get 14 and negative 2. So I am going to use the new rule that I did, where I take my a value, I put the variable next to it. I put my first factor, and I put it next to it. Now I do the same thing. My a value is a negative 4, and I take my negative 2, and I put it next to it. Now I look, is there a GCF I can take out? Well, here, they both have 2 in common. Here, because this is already a negative, and I want my a value to be a negative, I need to make this a positive, because a negative times a negative will give me a positive a value, and I don't want that. So I need to make this one be the positive, so I have a negative times a positive is a negative. Another way I like to think about it is if they're both negative here, it's always nice to take out the negative. So I divide by negative 2, because that's my GCF. 2 is my GCF. I could take it out as a negative. So one's a negative, one's a positive. So I get negative 2x plus 7. When I divide this, I get 2x plus 1. And that would be my factor form. And once again, I can find the zeros if I was asked to, which would be negative 7. I subtract it over, divided by negative 2, which is 7/2, and this would be negative 1/2. Let's take a look at one more problem so we fully understand what we're doing. So now I have this problem, and I'm always going to look, do I have a GCF I can take out? Well, I have a 6, I have a negative 25, I have a 24. All three of those numbers don't have a GCF other than 1, so I can't take anything out. So now I'm going to resort to seeing my A is not equal to 1. It's 6, so I am going to use my BAC. So my B is negative 25. My AC, 6 times 24 is 144. So I have to think what multiplies to 144 and adds to negative 25. And when I do that, I put it in my calculator, I find my factors. I find it's negative 16 and negative 9. So I'm going to do my rule. I take my A value, put it down, put one of my factors. I take my A value, bring it down, put one of my factors. Now I look, is there a GCF I can take out? They're both divisible by 2, so I can divide them both by 2. Then I use 6 divided by 2, negative 16 divided by 2. I look over here, is there a GCF I can take out? Up, they both are divisible by 3, so I'm going to divide by 3. So I get 3x minus 8. I divide by 3, I get 2x minus 3. Once again, that's my factor form. It asks me to factor. That would be my final answer. But if they ask me for my zeros, it would be 8/3 and 3/2 because I set both of those binomials equal to 0 and solve that two-step equation. So I hope these were helpful to determine how to factor in a quicker, efficient manner when our A value is not 1.